Section 2.4 discusses the continuity of functions. So let's examine these three different functions and recall that x equal to 2 is not in the domain of the following functions. So here's x equals to 2. Even without knowing a formal definition of continuity, we could make a guess about the continuity of these functions. For example, for a function to have continuity, it should be continuous, or it should continue on. So we can see that there's some problems here. In this one, we have a hole in the graph, and that's not really a big problem. We could just come along and just skip right over it. It wouldn't be so bad, and then we could continue on. In this function, we could be going along, and then we would have to make some sort of a jump, but then we could keep going. In our third graph, we have a vertical asymptote at x equals to 2. And we have a much bigger problem there. If we were going along from the left, there is no way for us to get across that vertical asymptote. We are just continuing to infinity. So we can make the estimation, and I think it stands to reason that we can say that these graphs are not continuous. But let's examine the formal definition. Okay. So by definition, a function f of x is continuous at a point A. We'll just look at continuity at a point for a moment. If and only if the following three conditions are satisfied. So we'll go through them one by one. So what we do have is that f of a, that point, wherever we're at, x equal to a, the function has to be defined there at f of a. So in our case, we were working with a is equal to 2 in the previous example, and here's 2. And the problem with this hole in the graph is that f of a, or in our case, f of 2, is not defined. And therefore, looking at the rules of continuity, the definition of continuity, we can say that this function is not continuous. But where is it not continuous? It's not continuous at x equal to 2. We also have that the limit as x approaches a of f of x needs to exist. So again, we're working with 2. Right. And we can see that as we approach 2 from the left-hand side, the limit as x approaches 2 from the left-hand side of our function f of x, this is g of x, sorry. G of x is equal to -1. Whereas if we come from the right, so if we approach the limit as x approaches 2 from the right of g of x, well, that's equal to +1. And these two are not equal. So what that means then is that the limit as x approaches 2, the full limit of g of x, does not exist. So this graph violates, and this function violates, condition 2 of continuity, that the limit as x approaches a exists. So again, we can say this is not continuous. Okay. In our third example, again, we have this vertical asymptote here at x equals to 2. So f of a is not defined, or f of 2 is not defined. So that violates the first condition, so we could automatically say this is not continuous. But it also violates the second condition because the full limit as x approaches 2 of, I guess this is h of 2, h of x, does not exist. So we didn't even get to the third condition. Once we've validated that f of a exists and that f of x, the limit of f of x as x approaches a exists, once those two are validated, then we have to check the condition that those two are equal. Okay. When we have that, that is our full definition of continuity. So on this next page, what we have is some strategies for you to problem solve this. The step number one is going to be to check and see if f of a is even defined. If f of a is not defined, we can stop. Okay. If f of a is defined, on the other hand, then we'll proceed to number two. We're going to compute the full limit as x approaches a of our function. And you might have to calculate the left-hand limits and the right-hand limits to get this done. If that limit doesn't exist, you can also stop and say the function is not continuous. If that limit does exist, then we have to check the comparisons, and we'll compare f of a and the limit as x approaches a of our functions. And if the limit is not equal, then we will also say that this function is not continuous. If it is, all three criteria for continuity has been met, and we will say that the function is continuous at our point x equal to a.